Welcome to Ask and Learn.
So in this question, we have been asked to balance the redox chemical reaction. And again, we will start with taking the two halves reaction. So we'll start with part A. So the first half of the reaction is NO2 goes to NO3 negative. Okay, so now since the nitrogen atom is already balanced, we will start with oxygen atoms. So on left hand side we have two oxygen atoms, and on right hand side we have three oxygen atoms. So we will add one water molecule here. And now to balance the hydrogen atoms, we will add two H positive here. Okay, and now we will add the electrons. So on right hand side or the left hand side we have zero electrons, and on left hand side on the right hand side we have one positive charge, so we will add one electron here. So this is a oxidation reaction since we end up losing the electrons. Okay, and for the next half of the reaction, which says that NO2 goes to NO3, NO2 negative. Now in this reaction we will start with just balancing the electrons. Since nitrogen and oxygen are already balanced, so we will just end up having one electron here this side. So this is the reduction reaction. And now we have to add the two reactions, so this gets cancelled very easily, and we end up having H2O plus 2NO2, and it goes to NO3 negative plus NO2 negative plus 2H positive. Now since this reaction is in a basic medium, we have to add OH negative ions. So to balance the H positive ions, we will add two OH negative ions here, and we will add two OH negative ions here. So the overall reaction comes out to be, so this will end up forming two water molecules, and we will end up having 2 NO2 plus 2 OH negative going to NO3 negative plus NO2 negative plus 2 water molecules minus 1 water molecules, which is on the left hand side, to give 1 water molecule on the right hand side. Now since NO2 is going to plus 4 to plus 5 oxidation state in one reaction, and plus 4 to plus 3 oxidation state in one reaction, which means NO2 is the oxidizing agent as well as reducing agent. Okay, so this is part A, and now we move to part B. So part B, once again we will divide the reaction into two halves. So the first reaction is that zinc goes to ZnOH4 2 negative. Okay, and now we have to balance the oxygen atoms first. So on the right hand side we have four oxygen atoms, and therefore we will add four water molecules on the left hand side. And now we have 8 H positive or 8 hydrogen atoms on the left hand side, and 4 H positive or 4 hydrogen atoms on the right hand side. So we will add 4 H positive more. And now we have to balance the charge. So left hand side has 0 charge and right hand side has 2 positive charge. So we will end up adding 2 electrons, and this is the oxidation reaction since we end up losing electrons. Okay, now in the next half of the reaction, we have NO3 negative going to form NH3. Okay, that is ammonia. So on the left hand side we have three oxygen atoms, so we will end up adding three water molecules on the right hand side, and then the right hand side will have 6 and 9 hydrogen atoms, so we will be adding 9 H positive on the left hand side. And now right hand side has 0 charge, whereas left hand side has 8 positive charge, so we will end up adding 8 electrons, and therefore this is the reduction reaction since electrons is gained over the course of the reaction. Now to add this reaction we have to equal the number of electrons, so we will multiply the oxidation state by um, we will multiply the oxidation state by 4, okay, to balance the number of electrons. So this gets cancelled, and the overall equation come out to be 4 zinc plus NO3 negative plus 13 water molecules. So why 13? Because 4 into 4 is 16 and we have 3 water molecules here. So 16 minus 3 is 13. And then this will form 4 zinc OH4 2 negative plus, and since we have 16 H positive here and 9 H positive here, so 16 minus 9 is 7. So 7 H positive here and then NH3. Okay, and now since this equation is in a basic medium, we have to add number of hydroxide atom basically to balance the H positive ions. So what we will do is we will add 7 OH negative this side, and then we will add 7 OH negative this side. So this in total will form 7 water molecules, and 13 minus 7 is how much? 6. So the overall reaction come out to be 4 zinc plus NO3 negative plus 7 OH negative plus 6 water molecule goes to 4 zinc OH4 2 negative plus NH3. So this is our overall balanced reaction. Now if you see, nitrogen in nitrate ion goes from plus 5 to minus 3 oxidation state, which means the oxidation state is decreasing, and therefore this is the oxidizing agent. Whereas zinc goes from 0 oxidation state to plus 2 oxidation state, right? And therefore the oxidation state is increasing, therefore this is the reducing agent. Okay, so this is part B, and now we shall go to part C. So the part C, again we'll do the same thing. We will divide the reaction into two halves. So the first reaction will be H2S goes to S8. Okay, so first we will balance the sulfur atoms. So we'll put 8 here, and now we don't have any oxygen atoms, so we'll straight away go to hydrogen atoms. So we will have 16 H positive ions here, and then we'll balance the number of electrons by adding 16 electrons this side, because there is zero charge on the left side. So we'll have this is the oxidation reaction. And now the next reaction, which is nitrate going to NO. So we don't have to balance the nitrogen atom because it's already balanced. We just have to balance the oxygen atoms and the hydrogen atoms. So we'll end up adding 2 water molecules here to balance the oxygen atoms, and 4 H positive on the left hand side to balance the hydrogen atoms, and then we will end up adding 3 electrons here to balance the charge. Okay, so this is our reduction reaction because it undergoes gain of electrons. Now since we have to balance the number of electrons, we will end up multiplying this with 3 and this with 16. Okay, and we will sum up the two reactions. So this will come out to be 8 into 3 is 24. So 24 hydrogen sulfide plus, we will have 64 H positive here, and we will have 48 H positive here. So 64 minus 48 is 16. 16 H positive plus, and we will have 16 nitrates. So, and then we will have 3 S8 molecules, and we'll have 16 NO plus, now water molecules. Now here we will have 32 water molecules, and here we will have 24 water molecules. Oh sorry, we don't have any water molecules here. Sorry about that. That's hydrogen sulfide. So we will have 32 water molecules here. So, and that's it. And we will write that in the final equation. So yeah, this is our balanced chemical equation. Since this was in the acidic medium, we don't have to add any hydroxides. So if you see, in H2S the sulfur goes from -2 to 0 oxidation state, so this is our reducing agent. And nitrogen in nitrate goes from +5 to -2 oxidation state, and therefore it's a decrease. So this is our oxidizing agent, which means it's oxidizing hydrogen sulfide by itself getting reduced. So yeah, hope that